Today is the 8th of September 2023, and I'd like to talk to you about linear equations. Thank you to everyone who has been watching our videos. Okay, please, can you consider subscribing, sharing, liking, and following us especially on which platform you are following from, okay, watching from, okay. So for instance, if it's on YouTube, you can subscribe and share and like and give us comments on how the video is helping you. Okay, I will appreciate that a lot. Please, I normally write, please follow my notes/scripts. Okay, normally, as you know, maths has a lot of words and numbers. Okay, it hasn't got a lot of these, but I just want to make you aware that in case you have a situation like that. So for instance, this is 4:5, not 5:4. Okay, so if I say 5:4, I will still do it as 4:5 on the notes. Okay, so maybe I was just trying to get ahead of myself. Okay, these things do happen sometimes, not all the time. Okay, so I'm just trying to make amendments on that. Okay, but otherwise everything on my notes is right because I've done it, gone over and over again. If it's not right, I'll come the next video, I'll correct it, and I'll also put that in the comment section. Is that okay? Thank you very much on that. Please beware of scammers. Don't be scammed. Don't give your money to anyone that you don't know. And if it's somebody you know, make sure it is that real person, because I'll not be asking you to donate money under any circumstances. Okay, thank you for very much on that. I'll recap. Last lesson, we look at travel graphs or time graphs, okay, where maybe you travel from one place to another, you make some stops. So we found a way of drawing them. I showed you how to do it step by step, okay, and I showed you how to, if you do the math and you get the axis right, then you shouldn't worry, because everything will fall into place. In the end, you are going to do only one graph. Okay, I did it step by step just to explain. Okay, but in answering questions, you only need to do the end graph. Okay, do the math to get the scale right, which is very important. So in the beginning, I will see how much time is involved, okay, or how many minutes, how many hours, and use that to do my scale, okay, and then how many kilometers or miles is involved, and put it on the right axis. Okay, then after you've drawn your graph, then it becomes easy, because answering the questions are fairly easy on time and travel graphs. Okay, I'll start that today. Okay, a supermarket sells two types of bottled water in a ratio 4:5. They have a total of 6,000 bottles of both in stock. Work out each quantity. Okay, so they have it in stock and they normally sell it in the ratio of 4:5. So when they are ordering, they order it in that ratio, okay, so that they don't order the same ratio, so that they don't have uh, a lot of leftover of one kind, because they know that this is how it sells. Okay, now let B1 be bottled water 1 and B2 be bottled water 2. So B1 is to B2 is 4:5. Okay, now the total ratio is 9. So B1 will be 4/9 times 6,000 bottles. B2 will be 5/9 times 6,000 bottles. Here I'm using the calculator. Okay, so I'll do 4 times 6,000 and then divide by 9. 4 times 6 is 24, so on the calculator that will be 24,000 divided by 9. So if I divide by 9, I have 2,666.7, and I approximate it as 2,667. Okay, the other one also is 5/9 times 6,000. 5 times 6 is 30, so 30,000 divided by 9, which is 3,333.3. Now I ended up approximating because I can't have 2,666.7 bottles of water. Okay, the bottles of water it should be a whole bottle. Okay, if it's in stock and it's brand new. So my answer will be 2,667 for B1, and here 333 for B2, 3,333 for B2. Okay, because they are bottles of water. They are not going to be half bottles, 0.3 bottles. No, it is full bottle. Every bottle is counted as one. So here again, as we can see, we leave our answer as whole numbers. Okay, not as a decimals. Okay, so if you add both, you end up getting 6,000 bottles. So let's see what we want to do today. Today we are going to look at linear equations. Okay, now this is the easiest type of equation to solve. Okay, we've been looking at it. It's just that we've not said is that. Okay, but this is the easiest type of equation to solve. Okay, the unknown variable is always to the power of 1. So ax, it can be to the power of 2. So you can have 2x plus 3. Okay, 2x squared plus 3 is no longer linear. The x or the variable, so you can have by plus 7 equals 8. Okay, so it has a form ax plus b equals c. A is never equal to 0, because if A is 0, then this part of the equation doesn't exist. Then B equals C. Okay, so A is always to the power 1. Okay, that is a linear equation. It is always to the power 1. Okay, here also B cannot be 0. B cannot be 0. Okay, so you can have B to be 1, so Y plus C equals D. Okay, Y equals MS plus C. This is the formula for a straight line. Actually, that is where we get the linear equation from, which I will explain in the next few days, where M is the gradient and C is a constant, which is the intercept. But I will explain. Okay, so here too, X can never be 0. Okay, it is always equal to 1, and it's the power 1 if it will be a linear graph. Okay, it has only one variable. Okay, so the variable is either X or Y or B or 6. It's always one variable. Okay, a sample of linear graphs that we'll solve later today. So 7x plus 5 equals 12. X is the power 1. With the variable here is X. Okay, so AX plus B equals C. Okay, 2y plus 3 equals 15. That is our variable Y. 3z plus 5 equals 21. Our variable is Z. Y plus 2 equals 14. Here we have 1y. We said A can never be equal 0, because if A is 0, then the Y doesn't exist. Okay, so, and what the variable is always the power 1, no more than 1. So if you have y squared, it's no longer a variable, a linear equation. 45x minus 3 equals 18. 15c plus 2 equals 33. 5d plus 7 equals 12. 14r plus 3 equals 31. Okay, so these are examples of linear equations with just one variable. Okay, here are the I'm going to give you examples of non-linear variables. So these are not linear because it has two variables. Okay, the variable should either be A or B, but here there are two variables. So this is not a linear graph. A linear equation, sorry, we are talking about equation, not graphs. Okay, after this, hopefully we'll do graphs, linear graphs. Okay, so 5a plus 3b equals 10. It's not a linear equation. I'm talking about this linear equation because of the two variables. 14x plus y equals 6. The variable here is x and y. so it's not a linear equation. 3r plus x equals 14. Here again we have two variables, r and s, so it's not a linear equation. 11c plus d equals 20. Here again, two variables, c and d, so it's not a linear equation. So if it has two variables, then it's not a linear equation. Another, it should only have one variable. Okay, the variable is squared. So for instance, x minus 1 all squared, because if we break this down, we'll have s squared equals something, equals 8. So this is also not a linear equation. Y squared, straight away, this cancels it out. It cannot be a linear equation, okay? Y plus 3 all squared. Y squared, if we simplify, we'll have y squared and something equals 1. It cannot be a linear equation. 14r squared, because of this r squared, this is not a linear equation, okay? So two variables, one of the variables squared, those are not linear equation. A third one to consider is when the variable is a denominator. So even though there's one variable, when you simplify this, you are going to get y squared in the equation. So if one variable is a denominator, even though it has the same one variable, it's not a linear equation. Sorry. Because if we find the denominator and we simplify this will end up multiplying the y. We are going to get 3y squared somewhere. So it's not a linear equation. So straight away, when one variable, the variable is a denominator as 5 divided by 3y plus 7 equals y minus 3. It won't be a linear equation. 6 divided by 2x minus 4 equals x plus 16. This will also not be a linear equation, because at the end of it all, we are going to get something x squared. 2 over p minus 7 equals 2p plus 4. This will, because of this p here, it can't be a linear equation. 8 divided by q minus 17 equals q minus 3. Because of this q here, okay, this equation also will not be a linear equation. So when it has two variables, when the variable is squared and when the variable is a denominator, they will not be a linear equation, okay? A linear equation always has one variable. So now, solving linear equations, okay, we solve some equations that are linear, but today I'm only showing you. So here, ax plus b equals something, okay? So we are going to solve this. So 7x will be equal to 12, which is here. If we move the 5 there, it will be minus 5. This is plus 5. So if it comes to the other side, it becomes minus 5. 12 minus 5 is 7. So we have 7x equals 7. So x is 1. If we put x is 1 into this equation, 7 times 1 is 7. Add 5 is 12. So x equals 1. The second example, okay, I'm solving the examples I gave you here. I gave you 8 examples here. The examples of the linear equations. So I'm going to use that to solve them. By now, you should be able to solve them. But if you are still struggling with it, this is how we solve them. Okay. 2y plus 3 equals 15. So 2y equals 15 minus 3 because it's plus here. So if you want to move it to the other side of the equal to sign, it becomes minus 3. 2y equals 12 because 15 minus 3 is 12. Now y equals 12 divided by 2, which is 6. Okay. So if we put 6 into this equation, 2 times 6 is 12 plus 3 is 15. Okay, so that's why our y is 12. 3z plus 5 equals 21. 3z equals 21 minus 5. Okay, because the 5 is plus here. So if it goes to the other side, it becomes minus. 3z equals 21 minus 5, which is 16. Z equals 16 divided by 3. Okay. We can't reduce it any further, so that will be our answer. And if you put z back into this equation, you are going to get 21. Okay, if you put z equals 16 divided by 3, okay, back into this equation, you will get 21. The next example, y plus 2 equals 14. Okay, this is fairly straightforward. So y equals 14. 2 moves to the other side of the equal to sign. It becomes minus 2. So y equals 12. Okay, so 12 plus 2 equals 14. Now, 45x minus 3 equals 18. So 45x equals 18 plus 3. 45x equals 21 because if we move minus 3 to the other side, it becomes plus 3. That is why we got the 21. So to have s on its own, we are going to divide both sides by 45. So we have 21 divided by 45. Now 3 can go into 21 7 times. And 3 into 45, we have 15. So our answer is 7 over 15. If you put 7 over 15 back into this, replace it by s, you should get 18. Our next example, 15c plus 2 equals 33. Okay, so straight away we want to get rid of the 2. So we move it to the other side. It's plus 2 here. So if it comes to this side, it becomes minus 2. So 15c equals 33 minus 2. 15c equals 31. Because 33 minus 2 is 31. So c now on its own will be 31 divided by 15. So d, remember we are talking about linear equations and it only has one variable, okay? And d here is our variable, okay? So 5d plus 7 equals 12. 5d equals 12 minus 7. Because this is plus 7, it moves to the other side of the equal to sign. It becomes minus 7. 5d equals 12 minus 7, which is 5. d equals 5 divided by 5, which is equal to 1. Now, if we put 1 in place of d, we have 5 times 1, which is 5, plus 7, which is 12. You can easily do this in an exam just to make sure that your answer is right. Okay, our last example for today. 14r plus 3 equals 31. 14r equals 31 minus 3. Because this is plus 3, you move it to the other side. It becomes minus 31. So 14r equals 28 because 31 minus 3 equals 28. Therefore, r equals 28 divided by 14. So, which is 2. So, r equals 2. We put it back into the equation. 14 times 2, 28, plus 3 is 31. So, to go over what we've learned, a linear equation will have only one variable. Okay, so ax plus b equals c. The constant attached to the variable is never 0. That's why I wrote here a is never equal to 0. Because if it's equal to 0, then everything equals 0 here. So you have b equal to c, and then there's no variable then. So a linear equation has always a constant which is 1 or greater than 1, or a negative integer but not 0. Now, I've given you examples of linear equations which we've solved. I've also shown you why some equations can never be linear when there are two variables, okay, like a and b, like in these examples. When one variable is to the power 2 or squared or cube, those are not linear equations. And if the variable, this looks like it has only one variable, but 1 is a denominator. So after simplifying this part, okay, and you end up multiplying the y, so you end up getting y squared. So this is also not a linear equation, okay. So, and then we've gone on to solve some questions. So thank you very much for watching our lesson today, and I'll see you in the next.